So yesterday was an insane day in the AI world. I mean, truly, no BS, one of the craziest days I've seen in terms of just sheer AI news and advancements. Now, the OpenAI Sora text-to-video model was such a big thing that I had to just cover only it yesterday. I didn't have time to cover anything else. Here we are today to cover the rest of the news that happened yesterday, more or less. And oh yeah, guys, you might notice a few changes. How cool is that we actually have a lemon light? I know these lights can be a little bit bright sometimes, but I'm planning on fixing that issue. This one's a little hard to see too because it's reflective, but this is just like a cowboy frog. I don't know. I found it online and I thought it looked cool. And then Bold and Brash has been moved. So yeah, guys, we're moving up in the world. We have unlocked the power of LED signs. So not sure how many of you guys actually heard about this, but this was the first big deal announcement of yesterday. Gemini 1.5 Pro, a highly capable multimodal model with 10 million token context length, which is pretty unheard of. That's a huge deal. Of course, the OpenAI Sora model overshadowed this whole announcement, and some people were even thinking, it's a little suspicious, Google actually releases something useful and then OpenAI comes and drops the mic on something else. Anyways, it can support millions of tokens worth of multimodal input. The multimodal capabilities mean that you can actually interact with the model in ways that you wouldn't be able to previously. You can input entire books, for example, entire YouTube videos that are an hour long, massive collections of various documents or statistics, code bases that are hundreds of thousands of lines across. So yeah, those examples here are pointed out by Jeff Dean on Twitter, who is the chief scientist of Google DeepMind in their research. Anyways, let's check out the Google blog post. Our next generation model, Gemini 1.5, like a few weeks or a week after they just announced the brand new Gemini Advanced ? It's a little strange. It's almost like the release of Gemini Advanced was kind of a flop for them, so they needed to push something else out to stay relevant, I guess. Apparently, Gemini 1.5 delivers dramatically enhanced performance, building upon research and engineering innovations across their foundation model development and infrastructure. So they're saying that Gemini 1.5 is efficient to train and serve with a new mixture of experts architecture. If you'd like to learn more about that, they do have a paper on it as well. So the first Gemini 1.5 model they're releasing for early testing is going to be Gemini 1.5 Pro, not Ultra, so this is their mid-sized multimodal model. And apparently on the large language model front, it performs at a similar level to 1.0 Ultra on the tests such as logic, creativity, etc. However, it has some significant enhancements. For example, it comes standard with a 128,000 token context window, which is right up there with GPT-4 Turbo. However, starting today, a limited group of developers and enterprise customers can try it with a context window of up to 1 million tokens via AI Studio and Vertex AI in private preview. Wow, so 1 million tokens is quite a lot more. I mean, orders and orders of magnitude more. However, can it maintain its consistency over all of those tokens? That's the real question. And I think a lot of people right now have doubts about Google, especially with that Gemini 1.0 Ultra announcement just not really being that much, kind of being too little too late. But apparently to all customers, eventually we will get the full 1 million token context window, which I could see being very useful. Again, books, code bases, massive amounts of documents, full podcasts and YouTube videos. So they know some difficulties like improving latency, reducing computational requirements, and enhancing the overall user experience. Seems like it's not fully baked in the oven yet. So here they give us a little graphic showing how much bigger Gemini 1.5 Pro can intake in terms of context. You can see GPT-4 Turbo's at 128,000 tokens, Claude 2.1 is at 200k, and Gemini 1.5 Pro all the way at 1 million. Now, you might see Claude 2.1 here and think, well, why don't people use Claude more if it has such a great big context window? Well, it turns out that the main issue with Claude's 200,000 token context window is that it's simply too much data for the AI to take in at one time, so it can't maintain consistent performance when utilizing that full 200k context window. So the main question we're going to have here is, with this 1 million token context window that's just absolutely massive, can it maintain its consistency over that? Is it going to start hallucinating? Is the model going to break down? You see, GPT-4 Turbo with 128,000 tokens, it's very consistent over time, especially in the benchmarks. Claude 2.1, not so much. So it remains to be seen with Gemini 1.5 Pro, but I'm really hoping that they have made some real strides in architecture that allow them to really boost up the amount of context their model can take in at once. Like I said, people are kind of wary about Google right now because their releases have been overhyped and kind of under-delivering. So it's their own transformer and, as mentioned earlier, MOE architecture. While a traditional transformer functions as one large neural network, MOE models are divided into smaller expert neural models. So depending on the type of input given, MOE models learn to selectively activate only the most relevant expert pathways in its neural network. Interesting research. So this specialization massively enhances the model's efficiency. So Gemini 1.5 can learn complex tasks more quickly and maintain quality while being more efficient to train and serve. These efficiencies are helping our teams iterate, train, and deliver more advanced version of Gemini faster than ever before. So they're doing some recursive work here. I assume OpenAI is as well. All these AI companies must be using AI to develop more AI, as silly as it sounds. So they give us a little breakdown of context window. I think a lot of you probably already will know what context window is, but in case you're new to this, it's made up of tokens, which are the building blocks used for processing information for a large language model. They can be entire parts or subsections of words, images, videos, audio, or code. The bigger the context window, the more information the model can input and take in. It's pretty awesome to see that it is multimodal, though. I mean, that's a huge deal. 1 hour of video, 11 hours of audio, code bases. In their research, they've successfully tested up to 10 million tokens. I mean, that's some big words there, Google. I hope you're legit about that. All right, so we got an example here. Gemini 1.5 Pro can understand, reason about, and identify curious details in the 402-page transcriptions from Apollo 11's mission to the moon. Okay, let's take a peek.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through a screen recording of example prompts using a 402-page PDF of the Apollo 11 transcript, which comes out to almost 330,000 tokens. We started by uploading the Apollo PDF into Google AI Studio. Find 3 comedic moments, list quotes from this transcript, and emoji. This screen capture is sped up. This timer shows exactly how long it took to process each prompt, and keep in mind that processing times will vary. The model responded with 3 quotes, like this one from Michael Collins, "I'll bet you a cup of coffee on it." If we go back to the transcript, we can see the model found this exact quote and extracted the comedic moment accurately. Then we tested a multimodal prompt. We gave it this drawing of a scene we were thinking of and asked, "What moment is this?" The model correctly identified it as Neil's first steps on the moon. Notice how we didn't explain what was happening in the drawing. Simple drawings like this are a good way to test if the model can find something based on just a few abstract details. And for the last prompt, we asked the model to cite the timecode of this moment in the transcript. Like all generative models, responses like this won't always be perfect. They can sometimes be a digit or 2 off. But let's look at the model's response here. And when we find this moment in the transcript, we can see that this timecode is correct. These are just a few examples of what's possible with a context window of up to 1 million multimodal tokens in Gemini 1.5 Pro.
Okay, wow. I mean, I gotta say, I'm pretty impressed with that. I'll admit that's probably the way I would go about trying to test out that model. I'd probably dump it a ton of information and just start asking it questions. Again, we don't know if that result is necessarily cherry-picked, and I was honestly really impressed by the parsing time, though, to parse all that information. It was like 30 seconds or something like that for all of the Apollo transcript. It's very impressive. I don't know if parsing is the right word there. That might be incorrect to say. Okay, so highly sophisticated understanding and reasoning tasks for different modalities, including video. For instance, given a 44-minute silent Buster Keaton movie, the model can accurately analyze various plot points and events, reason about the small details in the movie that could easily be missed. Okay, we got another little demo here.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through a screen recording of example prompts using a 44-minute Buster Keaton film, which comes out to over 600,000 tokens. In Google AI Studio, we uploaded the video and asked, "Find the moment when a piece of paper is removed from the person's pocket and tell me some key information on it with the timecode." This screen capture is sped up, and this timer shows exactly how long it took to process each prompt. And keep in mind that processing times will vary. The model gave us this response, explaining that the piece of paper is a pawn ticket from Goldman & Company pawnbrokers with the date and cost. And it gave us this timecode 1201. When we pulled up that timecode, we found it was correct. The model had found the exact moment the piece of paper is removed from the person's pocket, and it extracted text accurately. Next, we gave it this drawing of a scene we were thinking of and asked, what is the timecode when this happens? This is an example of a multimodal prompt, where we combine text and image in our input. The model returned this timecode, 1534. We pulled that up and found that it was the correct scene. Like all generative models, responses vary and won't always be perfect, but notice how we didn't have to explain what was happening in the drawing. Simple drawings like this are a good way to test if the model can find something based on just a few abstract details, like it did here. These are just a couple examples of what's possible with a context window of up to 1 million multimodal tokens in Gemini 1.5 Pro.
Somehow this is like the most impressive thing Google has done in a long time. Oh man, that is genuinely really cool. That's some capabilities we don't see from OpenAI. Really makes you wonder, guys, why didn't this just get announced with Gemini Advanced? It would have made the whole announcement way better. Relevant problem solving with longer blocks of code. When given a prompt of more than 100,000 lines of code, it can better reason across examples, suggest helpful modifications, and give explanations about how different parts of the code works.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through some example prompts using the Three.js example code, which comes out to over 800,000 tokens. We extracted the code for all of the Three.js examples and put it together into this text file, which we brought into Google AI Studio over here. We asked the model to find 3 examples for learning about character animation. The model looked across hundreds of examples and picked out these 3. One about blending skeletal animations, one about poses, and one about morph targets for facial animations. All good choices based on our prompt. In this test, the model took around 60 seconds to respond to each of these prompts. But keep in mind that latency times might be higher or lower, as this is an experimental feature we're optimizing. Next, we asked, what controls the animations on the littlest Tokyo demo? As you can see here, the model was able to find that demo, and it explained that the animations are embedded within the GLTF model. Next, we wanted to see if it could customize this code for us, so we asked, show me some code to add a slider to control the speed of the animation. Use that kind of GUI the other demos have. This is what it looked like before on the original Three.js site, and here's the modified version. It's the same scene, but it added this little slider to speed up, slow down, or even stop the animation on the fly. It used this GUI library the other demos have, set a parameter called animation speed, and wired it up to the mixer in the scene. Like all generative models, responses aren't always perfect. There's actually not an init function in this demo like there is in most of the others. However, the code it gave us did exactly what we wanted. Next, we tried a multimodal input by giving it a screenshot of one of the demos. We didn't tell it anything about this screenshot and just asked where we could find the code for this demo, seen over here. As you can see, the model was able to look through the hundreds of demos and find the one that matched the image. Next, we asked the model to make a change to the scene, asking, how can I modify the code to make the terrain flatter? The model was able to zero in on one particular function called generate height and showed us the exact line to tweak. Below the code, it clearly explained how the change works. Over here in the updated version, you can see that the terrain is indeed flatter, just like we asked. We tried one more code modification task using this 3D text demo over here. We asked, I'm looking at the text geometry demo and I want to make a few tweaks. How can I change the text to say goldfish and make the mesh materials look really shiny and metallic? You can see the model identified the correct demo and showed the precise lines in it that need to be tweaked. Further down, it explained these material properties, metalness and roughness, and how to change them to get a shiny effect. You can see that it definitely pulled off the task, and the text looks a lot shinier now. These are just a couple examples of what's possible with a context window of up to 1 million multimodal tokens in Gemini 1.5 Pro.
That one was a little bit longer, but I think to everyone who knows how to code and understands how complex something like this is, it's really impressive. I mean, this is definitely stuff we have not seen before at all in the large language model space. This is pushing new boundaries. I'm sure that OpenAI and the rest of them are working on stuff that's very similar to this, but still, like, that is insanely impressive. Notice that that one wasn't in real time, though, so maybe it took a few tries to get that perfect. That's insane, though. It's really, really impressive what Google's done here. So then they get into a little bit more performance and extensive ethics and safety testing. Right now, it's only available to developers and enterprise customers, so it's not really public yet. But still, I really interpret this as shots fired towards OpenAI. And again, this was all yesterday before OpenAI announced their Sora text-to-video AI that stole the entire show. Again, if you want to get up to date on Sora, check out my video from yesterday, but I really do think that Google has something here. They're showing us what they're capable of, and they're definitely not one to give up on just yet. It's absolutely groundbreaking stuff. And I mean, honestly, guys, this Sora AI video generation model is like nothing we've ever seen before. It is just as impressive, if not more impressive, than the Google announcement. And it just shows that I think both Google and OpenAI are holding back a little bit. They probably have access to AI technology that we just don't really know about or we can't even conceive of. So we got to bring out that competition. That's sort of why I like to make these videos, one of the reasons. Check this demo out though. It can generate very accurate and good-looking Minecraft footage. I mean, that's pretty insanely accurate. Especially the hotbar. I mean, that's like actually perfect down there. And like the trees and the rest of the environment. It's shockingly good. And of course, all of these demos, I do believe they come from the research paper. But just imagine a future, if you will, with this OpenAI Sora video generation. If this can work on the fly, you could essentially have a video game that plays on the fly and generates graphics for you on the fly about anything. It could be about literally anything you imagine, so you could make your own custom character, own custom story. I mean, you could go really deep with this. Another Sora demo shows how you can do image inputs and you get really fantastic animated examples from them. So you can see the giant wave crashing through, and it really understands the context behind this image and how to actually animate it and create motion for it. So yeah, I mean, I'm not going to talk too much about Sora because I talked so much about it yesterday. If you want to learn about it, check out yesterday's video. But yeah, let's get into the other AI advancements that happened yesterday. So this one comes right from Meta. They're releasing something called VJEPA or VJEPA, a method for teaching machines how to understand and model the physical world by watching videos. They're able to understand and predict what is going on in a video, even with limited information about it. Similar to, let's say, if someone sat you down and asked you what you thought was going to happen in a video you're watching. Pre-trained on entirely unlabeled data, and they have competitive benchmarks to prove their results as well. Obviously, this is, all with the goal of advancing machine intelligence, its ability to understand our world. I do like this little video, by the way. All right, he rips the paper, and the model thinks that it's tearing something into two pieces. You can even go ahead and mask out some of the visual input from the video and then have the model reconstruct it with what it thinks it should look like, and it does a fairly decent job. This, of course, is video inpainting. You see, for these models to be able to understand what they're saying, they also need to essentially be able to recreate it. I mean, it is learning, machine learning after all, right? Anyways, they do indeed have a full website for this one, if you want to get into a little bit more of how it actually works under the hood. What's really cool is they did go ahead and release this open source in that traditional Meta AI fashion. However, a lot of you will point out and even tell me in the comments, yes, it is non-commercial at the moment. While you can download it and use it, there is a code of conduct here and a license that is non-commercial. But it is in the Creative Commons, which is pretty awesome. Gotta love Meta just releasing stuff. This is still far more open than, funnily enough, OpenAI or Google, Microsoft, any of them. Meta really does lead in this example. Next up here, Kria AI announced new settings for upscale and enhance, which is essentially like that magnific magic AI upscaler, but entirely free on Kria's website. This one could be a video in its own, but there's a bunch of different settings now that you can adjust, and you can change the upscaling factor. They've greatly improved it, more or less. And the fact that it's entirely free is pretty awesome. So hats off to Kria AI for building a competitive product to Magnific at much less the price, because the thing's basically free, where Magnific is actually very expensive. So next up, this is an awesome one that I think is going to fly under the radar. After months in private beta, Lindy is now open to everybody, and we actually looked at these AI agents, and I've had access to them for a while now. I haven't tested them in a little bit, so a video will probably be coming on this soon, but essentially these are AI agents that can work together and work for you and use a bunch of APIs and other products. Really awesome stuff. Again, I think this is going to end up being a full video, but yeah, Lindy is now out for everybody. But yeah, you can see 3,000 plus integrations out of the box: Gmail, Gcalculator, G Sheets, Outlook, Outlook, Slack. So many different things you can do with these little AI agent Lindies. They have guidelines, they have triggers, they have actions. It's a huge step forward. And yeah, like I said, these agents can actually be paired up to work together. I've tried it before. Sometimes it worked for me, sometimes it didn't, but it might be updated now, especially that it's releasing. So this one could make for a really great full video. Let me know if you want me to explore this a little bit more. It's going to be linked below though if you want to take initiative and go try this thing for yourself. They are quite magical. So like I said, guys, it's been an insane couple of days in the AI space and for the world in general, honestly, especially with those huge releases from both Google and OpenAI. I mean, there is a lot going on. If you'd like to stay the most up to date, you can always check out my Discord server where people are always posting stuff in the community. And you can also follow me on Twitter or X, whatever you want to call it. I've been uploading my full YouTube videos there, as well as just reposting all of the latest news in real time as I see it. Really excited for the future of technology. Also a little bit worried about a few things too, but with great power comes great responsibility, right? AI is both powerful and dangerous. Let me know what you think of these advancements. Honestly, like, especially with the Google and OpenAI stuff, I thought that we were like years away from that stuff, and yet it's here today, early 2024. We have to change our trajectory and our thought on AI. It is not slowing down, even though we might see dips, you know, things are still going on in the background. This is world-changing, life-changing technology. 50 years in the future, the world is going to look entirely different from the way it does today because of it. It's the next leap for humans. But I don't know, stick around with me if you'd like as we follow this crazy trajectory and explore the latest in technology. See you guys in the next one. Goodbye.